The AMD Accelerated Processing Unit, formerly known as Fusion, is a series of 64-bit microprocessors from AMD designed to act as a CPU and graphics accelerator on a single chip. AMD announced the first-generation APUs, Llano for high-performance and Brazos for low-power devices in January 2011. The second-generation Trinity for high-performance and Brazos 2 for low-power devices were announced in June 2012. The third-generation Kaveri for high-performance devices was launched in January 2014, while Kabini and Temash for low-power devices were announced in summer 2013. The Sony PlayStation 4 and Microsoft Xbox One 8th-generation video game consoles both use semi-custom third-generation low-power APUs. History: the AMD Fusion project started in 2006 with the aim of developing a system on a chip that combined a CPU with a GPU on a single die. The acquisition of graphics chipset manufacturer ATI by AMD was a key step toward realizing such a vision. The project reportedly required 3 internal iterations of the Fusion concept to create a product deemed worthy of release. Reasons contributing to the delay of the project include the technical difficulties of combining a CPU and GPU on the same die at a 45nm process, and conflicting views on what the role of the CPU and GPU should be within the project. The first-generation desktop and laptop APU, codenamed Llano, was announced on January 4, 2011 at the 2011 CES show in Las Vegas and released shortly after. It featured K10 CPU cores and a Radeon HD 6000 series GPU on the same die on the FM1 socket. An APU for low-power devices was announced as the Brazos platform, based on the Bobcat microarchitecture and a Radeon HD 6000 series GPU on the same die. At a conference in January 2012, corporate fellow Phil Rogers announced that AMD would rebrand the Fusion platform as the Heterogeneous Systems Architecture, stating that it's only fitting that the name of this evolving architecture and platform be representative of the entire, technical community that is leading the way in this very important area of technology and programming development. However, it was later revealed that AMD had been the subject of a trademark infringement lawsuit by the Swiss company Arctic, who used the name Fusion for a line of power supplies. The second-generation desktop and laptop APU, codenamed Trinity, was announced at AMD's Financial Analyst Day 2010 and released in October 2012. It featured PIL-driver CPU cores and Radeon HD 7000 series GPU cores on the FM2 socket. AMD released a new APU based on the PIL-driver microarchitecture on March 12, 2013 for laptops mobile and on June 4, 2013 for desktops under the codename Rickland. The second-generation APU for low-power devices, Brazos 2.0, used exactly the same APU chip, but ran at higher clock speed and rebranded the GPU as Radeon HD 7000 series and used a new I/O controller chip. Semi-custom chips were introduced in the Microsoft Xbox One and Sony PlayStation 4 video games consoles. A third generation of the technology was released on January 14, 2014, featuring greater integration between the CPU and GPU. The desktop and laptop variant is codenamed Kaveri, based on Steamroller Architecture, while the low-power variants, codenamed Kabini and Temash, are based on Jaguar Architecture. Features: AMD Heterogeneous System Architecture. AMD is a founding member of the HSA Foundation and is consequently actively working on developing the Heterogeneous System Architecture in cooperation with the other members. The following hardware and software implementations are available in AMD's APU-branded products: multi-monitor support. Multi-monitor setup based on AMD Infinity are also possible with AMD's APU-branded product line, as this video showing Civilization V running in 3x1 portrait mode on an Infinity-enabled AMD A10-7850K Kaveri proves. Video acceleration. Both unified video decoder and video codec engine are present on the dies of all APU-branded products. They are supported by AMD Catalyst and by the free and open-source graphics device driver ATI AMD. AMD True Audio. AMD True Audio is a new IP core for audio acceleration. It is only found on the Kaveri branded APUs. Feature overview: 1 maximum of 2 non-display port monitors, and a maximum of second number of display port monitors, but maximum of 6. APU branded platforms. AMD APUs have a unique architecture. They have AMD CPU modules, cache, and a discrete class graphics processor all on the same die, using the same bus. This architecture allows for the use of graphics accelerators, such as OpenCL, with the integrated graphics processor. The goal is to create a fully integrated APU, which, according to AMD, will eventually feature heterogeneous cores capable of processing both CPU and GPU work automatically, depending on the workload requirement. K10 architecture, Llano. Stars AMD K10 cores, integrated evergreen VLIW5-based GPU, Northbridge, PCIe, DDR3 memory controller to arbitrate between coherent and non-coherent memory requests. The physical memory is partitioned between the GPU and a CPU. Unified video decoder, AMD Infinity multi-monitor support, the first-generation APU, released in June 2011, was used in both desktops and laptops. It was based on the K10 architecture and built on a 32nm process featuring 2 to 4 CPU cores on a TDP of 65-100W, and integrated graphics based on the Radeon HD 6000 series with support for DirectX 11, OpenGL 4.2 and OpenCL 1.2. In performance comparisons against the similarly priced Intel Core i3-2105, the Llano APU was criticized for its poor CPU performance and praised for its better GPU performance. AMD was later criticized for abandoning socket FM1 after one generation. Bobcat architecture, Ontario, Zake-8, Desna, Hondo. Bobcat-based CPU, evergreen VLIW5-based GPU, branded Radeon HD 6000 series and Radeon HD 7000 series, Northbridge, PCIe support. DDR3 SDRAM memory controller to arbitrate between coherent and non-coherent memory requests. The physical memory is partitioned between the GPU and a CPU. Unified video decoder, the AMD Brazos platform was introduced on January 4, 2011, targeting the sub-notebook, netbook and low-power small form factor markets. It features the 9-watt AMD C-Series APU for netbooks and low-power devices as well as the 18-watt AMD E-Series APU for mainstream and value notebooks, all-in-ones and small form factor desktops. Both APUs feature 1 or 2 Bobcat x86 cores and a Radeon Evergreen series GPU with full DirectX 11, Direct Compute and OpenCL support including UVD3 video acceleration for HD video including 1080p. AMD expanded the Brazos platform on June 5, 2011 with the announcement of the 5.9-watt AMD Z-Series APU designed for the tablet market. The Desna APU is based on the 9-watt Ontario APU. Energy savings were achieved by lowering the CPU, GPU and Northbridge voltages, reducing the idle clocks of the CPU and GPU as well as introducing a hardware thermal control mode. A bidirectional turbo core mode was also introduced. AMD announced the Brazos T platform on October 9, 2012. It comprises the 4.5-watt AMD Z-Series APU and the A55T Fusion Controller Hub, designed for the tablet computer market. The Hondo APU is a redesign of the Desna APU. AMD lowered energy use by optimizing the APU and FCH for tablet computers. The Deccan platform including Krishna and Wichita APUs were cancelled in 2011. AMD originally planned to release them in the second half 2012. Pili driver architecture, Trinity and Rickland. Pili driver-based CPU, Northern Ireland's VLIW4-based GPU, Unified Northbridge includes AMD Turbo Core 3.0, which enables automatic bidirectional power management between CPU modules and GPU. Power to the CPU and GPU is controlled automatically by changing the clock rate depending on the load. For example, for a non-overclocked A10-5800K APU, the CPU frequency can change from 1.4 GHz to 4.2 GHz, and the GPU frequency can change from 304 MHz to 800 MHz. In addition, CC6 mode is capable of powering down individual CPU cores, while PC6 mode is able to lower the power on the entire rail. AMD HD Media Accelerator includes AMD Perfect Picture HD, AMD Quick Stream technology, and AMD Steady Video technology. Display controllers, AMD Infinity support for multi-monitor setups, HDMI, DisplayPort 1.2, DVI, Trinity. The first iteration of the second-generation platform, released in October 2012, brought improvements to CPU and GPU performance to both desktops and laptops. The platform features 2 to 4 PLE driver CPU cores built on a 32nm process with a TDP between 65W and 100W, and a GPU based on a Radeon HD 7000 series with support for DirectX 11, OpenGL 4.2, and OpenCL 1.2. The Trinity APU was praised for the improvements to CPU performance compared to the Llano APU. Rickland, enhanced PLE driver CPU cores, temperature smart turbo core technology. An advancement of the existing turbo core technology, which allows internal software to adjust the CPU and GPU clock speed to maximize performance within the constraints of the thermal design power of the APU. New low-power consumption CPUs with only 45W TDP. The release of this second iteration of this generation was March 12, 2013 for mobile parts and June 5, 2013 for desktop parts. Jaguar Architecture, Kabini and Temash. Jaguar-based CPU, graphics core Next-based GPU, supports the Mantle API, socket AM1 support. In January 2013, the Jaguar-based Kabini and Temash APUs were unveiled as the successors of the Bobcat-based Ontario, Zakate and Hondo APUs. The Kabini APU is aimed at the low-power, sub-notebook, ultra-thin and small form factor markets. The Temash APU is aimed at the tablet, ultra-low power and small form factor markets. The 2 to 4 Jaguar cores of the Kabini and Temash APUs feature numerous architectural improvements regarding power requirement and performance, such as support for newer x86 instructions, a higher IPC count, a CC6 power state mode and clock gating. Kabini and Temash are AMD's first, and also the first ever quad-core x86-based SoCs. The integrated fusion controller hubs for Kabini and Temash are codenamed Yangtze and Salton respectively. The Yangtze FCH features support for 2 USB 3.0 ports, 2 SATA 6 Gb ports, as well as the XHCIA 1.0 and SDSDIOA 3.0 protocols for SD card support. Both chips feature DirectX 11.1 compliant GCN-based graphics as well as numerous heterogeneous system architecture improvements. They were fabricated at a 28nm process in an FUT3 BGA package by TSMC, and were released on May 23, 2013. The PlayStation 4 and Xbox One were revealed to both be powered by 8-core semi-custom Jaguar-derived APUs. ARM server architecture, Seattle, a Cortex-A57-based 64-bit server solution SoC will be launched in the second half of 2014 and codenamed Seattle. The first AMD ARM chip has no GPU and is then not an APU, but later will be. Seattle will feature 8 or 16-core variants, with an expected clock speed over 2 GHz, and will reportedly deliver up to 4 times the performance of current Opteron X processors. These ARM processors will incorporate C-micro Freedom Fabric on die, offering up to 10 Gbps bandwidth, for server usage. Additionally, each ARM processor will support up to 64 GB RAM. Steamroller Architecture, Kaveri. Steamroller-based CPU with 2 4 cores, graphics core Next-based GPU with 192 512 shader processors, 15-95W TDP, socket FM2+, Heterogeneous system architecture enabled zero-copy through-pointer parsing. The third generation of the platform, codenamed Kaveri, was partly released on January 14, 2014. Kaveri contains up to 4 Steamroller CPU cores clocked to 3.7 GHz with a turbo mode of 4 GHz, up to a 512-core graphics core next GPU, 2 decode units per module instead of 1, AMD True Audio, Mantle API, and on-chip ARM Cortex-A5 MPCORE, and will release with a new socket, FM2+. Ian Cutress and Rahul Garg of Anantech asserted that Kaveri represented the unified system-on-a-chip realization of AMD's acquisition of ATI. The performance of the 45WA8-7600 Kaveri APU was found to be similar to that of the 100 West Rickland part, leading to the claim that AMD made significant improvements in on-die graphics performance per watt. However, CPU performance was found to lag behind similarly specified Intel processors, a lag that was unlikely to be resolved in the Brazos family APUs. The A8-7600 component was delayed from a Q1 launch to an H1 launch because the Steamroller Architecture components are alleged to not scale well at higher clock speeds. AMD announced the release of the Kaveri APU for the mobile market on June 4, 2014 at Computex 2014, shortly after the accidental announcement on the AMD website on May 26, 2014. The announcement included components targeted at the standard voltage, low voltage, and ultra-low voltage segments of the market. In early access performance testing of the Kaveri prototype laptop, Ars Technica found that the 35WFX7600P was competitive with the similarly priced 17W Intel i7-4500U in synthetic CPU-focused benchmarks, and was significantly better than previous integrated GPU systems on GPU-focused benchmarks. Tom's Hardware reported the performance of the Kaveri FX7600P against the 35W Intel i7-4702MQ, finding that the i7-4702MQ was significantly better than the FX7600P in synthetic CPU-focused benchmarks, whereas the FX7600P was significantly better than the i7-4702MQ's Intel HD 4600i GPU in the 4 games that could be tested in the time available to the team. Puma Architecture, Biermer and Mullins. Puma-based CPU, graphics core next-based GPU with 192 Euro 512 shader processors, supports the Mantle API, socket AM1 support, excavator architecture, Carrizo. Excavator-based CPU with 4 cores, memory controller supports DDR3 SDRAM and DDR4 SDRAM, 65A WTDP, integrates South Bridge. See also, AMD Bulldozer, AMD Mobile Platform, List of AMD Accelerated Processing Unit microprocessors, List of AMD Mobile microprocessors, Radeon, Unified Video Decoder, References. External links, AMD Fusion Family Official Website, HSA Heterogeneous System Architecture Overview on YouTube by Vinod Tipuraju at SC13 in November 2013, HSA and a Software Ecosystem, HSA.